Relay is an electronic component used mostly in large equipment. Sometimes some work has to be done automatically in the circuit, based on different situations. At that time our relay is needed. So let's find out what is a relay and how a relay works. Welcome to SD Robotics. What is relay? Due to the low output power of various types of sensors or control signals, we cannot connect them directly to a load. Relays are used to overcome this problem. A relay is a simple electromechanical switch. While we use normal switches to close or open a circuit manually, a relay is also a switch that connects or disconnects two circuits. But instead of a manual operation, a relay uses a separate electrical signal, which is called a control signal, which in turn connects or disconnects another circuit. Relays are also used to protect the circuit from an excess voltage or current. In the inverter also it works a lot, like when the light goes out, the relay is turned on, and the power comes out from the battery, so that we can run the fan or any device. If the light comes on, then it turns off again, and the incoming power goes directly to the battery. Due to this, the battery starts charging. Overall the relay works automatically, to turn the power on or off. So it is essential for you to know how the relay works, only then you will be able to understand it well, and after that, you can also make it. There are a total of 5 terminals in ordinary and essential relays. According to the picture, the name of one of the 2 terminals connected together is called NC, which is called a normally closed terminal, and the name of the other terminal is called NO, which is called a normally open terminal. The middle terminal of the 3 terminals connected together is called the movable terminal, because this terminal keeps shifting from one place to another, and the rest of the terminal is called the coil terminal, because both of those terminals are connected to the winding. Whether the relay is in off condition or on condition, it keeps on working. In the off condition, no current is required to activate the relay. But to do it in the on condition, to activate it, a separate electric current has to flow through the terminal of the coil. Due to which the coil inside it acts like a magnet, and it pulls the iron leaf lying on its side, due to which that leaf connects to the normally open terminal, which activates the relay. One thing that should always be kept in mind is that the movable terminal and normally closed terminal are always connected. Due to no current flowing through the coil, it is called relay is in off condition. As the current flows through the coil terminal, then the movable terminal leaf is moved from normally close to normally open. This means movable terminal and normally open terminals get connected. It is called relay is in on condition. Poles and throws. Relays can switch one or more circuits. Each switch in the relay is referred as a pole. The number of circuits a relay connects is indicated by throws. Depending on the poles and throws, relays are classified into single pole single throw, single pole double throw, double pole single throw, double pole double throw, single pole single throw. A single pole single throw relay can control one circuit and can be connected to one output. It is used for applications that require only an on or off state. Single pole double throw. A single pole double throw relay connects one input circuit to one of the 2 outputs. This relay is also called a changeover relay. Double pole single throw. A double pole single throw relay has 2 poles and a single throw, and it can be used to connect 2 terminals of a single circuit at a time. For example, this relay is used for connecting both phase and neutral terminals to the load at a time. Double pole double throw. A double pole double throw relay has 2 poles and 2 throws for each pole. In motor direction control, these are used for phase or polarity reversal. Let's try to understand the working of a relay with an example. In this picture, we can see that we have taken 2 bulbs, which run on 220 volts AC current. One point of the first bulb and one of the second bulb are connected to normally open and normally closed terminals of the relay respectively. The other 2 ends of the bulbs are connected to the neutral of the voltage source. The relay's movable terminal is connected to the live wire of the voltage source. Initially, the normally closed terminal is connected to the movable terminal, so that the source current flows through the normally closed terminal, through the second bulb and returns to the source, and completes the circuit. As a result, second bulb will light up. Now if we want the first bulb to wake up, and the second one to turn off, then for this we have to pass current through the coil terminal of the relay, so that the movable terminal disconnect from normally close and gets attached to normally open. Now that the source current flows through the normally open terminal, through the first bulb and returns to the source, and completes the circuit. Before this, the first bulb starts to light up and the second bulb turns off. This is the fundamental working of a relay. With its help, we can also prepare work tools. Now we will know some specifications of the relay. We mainly use 5-pin relays in our projects. The image on the left is a 5-pin single-pole double-throw or SPDT relay. The 5 pins of this relay are respectively coil 1, coil 2, common terminal, normally closed and normally open terminals. The voltage at which a relay operates is called the operating voltage. Relays are available in different operating voltages, such as 5 volts, 6 volts, 12 volts, and 24 volts. As a result, we can easily use relays in circuits of different voltages. Also, when we need more than one relay, we can use these multi-channel relay modules, which makes our work much easier. Types of relays. Relays can be classified into different types depending on their functionality, structure, application, etc. We listed out some of the common types of relays here. We will mainly discuss 4 types of relays, which are the latching relay, solid-state relay, thermal relay, and reed relay. Latching relay. The latching relay is the relay that, if we activate it with electricity, the position at which the relay moves is as follows. Even if the coil has stopped the flow of electricity, its position does not change. To deactivate the relay, the current has to flow through the deactivator coil. Let us look at the working method of latching relay through an example. In the diagram we see that there are 3 circuits in total. The first is the activator circuit, the second is the external circuit with a bulb attached to it, and the third is the circuit of the deactivator. A coil and a button are added to the circuit of the activator and deactivator. Similar to the ordinary relay, there is a moving piston. Now if we press the button of the activator circuit, then the activator coil will be energized, and the piston will attract. This will move the piston to connect the common and normally open terminals, and the bulb will light up. This time, even if we release the button, the piston will remain in place and the bulb will continue to glow. To return the piston to its previous position, we have to press the button on the deactivator circuit. This will energize the deactivator coil and bring the piston back to its previous position. This is an example of a simple single-pole single-throw relay. Latching relays are made using more different methods. I hope this example contains the basic concept of the latching relay. Solid-state relay. Solid-state relay performs input-to-output isolation and switching functions without the use of moving parts, in contrast to electromechanical relays, which operate and switch a supply using coils, magnetic fields, springs, and mechanical contacts. Instead, the solid-state relay uses the electrical and optical properties of solid-state semiconductors. Like other relays, it has a control section and a load section. One of the main components of a solid-state relay is an opto-isolator, also called an opto-triac, which contains one infrared light-emitting diode, and a photosensitive transistor within a single case. The opto-isolator isolates the input from the output. Let us look at the working method of solid-state relay. When a current passes through the LED, it illuminates and its light is focused across the gap to a phototransistor or phototriac. This phototriac starts to flow current through itself and activates the load-switching triac. As a result, a connection is established between the 2 load terminals, and current flows through the load. Solid-state relay have fast switching speeds compared with electromechanical relays, and have no physical contacts to wear out. Thermal relay. One of a material's basic qualities is its coefficient of expansion. There is always a difference in the linear expansion of 2 distinct metals. Due to the unequal linear expansion of the 2 distinct metals, a bimetallic strip will always bend when heated. A thermal relay operates based on the metal's aforementioned characteristics. Construction of thermal relay. Thermal relays are incredibly easy to build. The bimetallic strip contains metals A and B. Metal B has a higher expansion coefficient than metal A. A heating coil is mounted on the bimetallic strip. When overcurrent flows through the heating coil, it heats up the bimetallic strip. Both metals expand as a result of the heat produced by the coil. The expansion of metal B, however, is greater than that of metal A. Due to this dissimilar expansion, the bimetallic strip will bend towards metal A. When the strip bends, the normally open contact closes, energizing the trip coil of a circuit breaker in the process. This type of relay is generally used for overload protection. A reed relay is a type of relay that uses an electromagnet to act directly on reed-like contact of a reed switch. Reed relays are small and fast-acting. They require a much lower level of power to actuate them than other traditional types of relay, and as a result they find many uses in various forms of electronic circuits. Let's try to understand the working principle of a reed relay. The switch is made from two thin, flat strips of ferromagnetic material called reeds, with contacts on the overlapping ends. Leads are connected to the outside ends of the reeds and the entire assembly is sealed in a hermetic glass tube. A coil is wound around the glass tube. The reed relay uses an electromagnetic coil. When there is no coil current, the reeds are in the open position. When there is current through the coil, the reeds make contact because they are magnetized and attract each other. Through this video, I tried to give an overview of the relay. Since the relay is a key component in various electronic circuits, a basic understanding of it is essential. I hope you liked the video informative. If you like this video, please hit the like button, subscribe to the channel, and share the video with your friends. I will come back to you soon with another informative video like this.